I'm Todd Snapp. I'm a design principal at the Chicago office of Perkins&Will.
And for several years now, you've been leading a pretty unique research project into tall timber design. Mm-hmm. You're sitting right in front of it. What is River Beach Tower?
So River Beach, it's a project that was actually initiated back in 2016. And it started, we were approached by Cambridge University in the UK, their material sciences college. And they were looking to create a professional academic partnership that started exploring the possibilities of mass timber and high-rise construction. So 2016, around that time, there were a handful of studies, some of them up to about 40 stories or so. But they were really interested in sort of bringing the research out of just the academia and creating this professional academic partnership. And at the time, we were also working here in Chicago on a large master plan on the south branch of the Chicago River called Riverline. Massive project, at least a 10-year time frame. And we thought it would be just a great opportunity to have some site-specific constraints that we could use to inform the research. So the genesis of River Beach was really loosely taking some of the program that we were working with for the master plan and creating this parallel exercise and creating a site-specific case study site that we could design a project to. And Cambridge's main interest was really to just understand the potential of what it means to go tall. So we applied a few constraints just to keep the exercise focused, right? Obviously there's a lot of issues to deal with, fire, mechanical systems, programs, clients. Mm-hmm. So what was interesting about the opportunity was we took some of those, constraints and programmatic elements that we were working with on the master plan and established a set of variables. For example, we wanted to have a building typology to study timber with. So residential made a lot of sense, mostly because of its scalability, its modularity. Like I said, there were a handful of studies at the time. If we were going to look at something like this, we wanted to push the limits. So, we selected 800 feet. Let's see what it means to build 800 feet, which is still a fairly practical height if you think of high-rise construction. Mm-hmm. So 800 feet, 80 stories, and then I think most importantly, the big variable we set was we wanted to really study for structure only. So we were able to sort of, keep in the back of our minds a lot of these other, parameters that would need to be solved, but to really get to a resolution on the study, keeping it focused on just the structure was really, the primary element. And there's a funny story. So the partnership was ourselves, Thornton Tomasetti, and Cambridge University. So Thornton Tomasetti being the structural engineering expertise. And Alejandro, one of the speakers in the exhibit tonight, I remember one of the first workshops, we simply modeled up just a generic residential massing 80 feet wide, about 160 feet long, made it 800 feet tall. They went and did some structural analysis, and the next meeting, Alejandro comes back, and it was something along the lines of the bottom third of the building would need to be solid wood for this to stand up. Which is, so if you think of, so that was, instead of seeing that as, we sort of saw that as just an opportunity. Okay, well, how can we make this work? So we took that sort of standard residential typology and just split the floor plate in half, which started to inform the design iterations. So that gave us a broader footprint. And then we kind of worked backwards and said, okay, well, how big do we want the windows to be at the base? And let's reverse that process in the tower. So it was those few constraints and then opportunities that really led, and the iteration of those that led to the design. And then, Cambridge's main goal was to really have a kit of parts that they could bring back to their labs in the UK and have some specific dimensions, material types, things like that were based on the research, that they could do things like fire tests, compression tests, and also start to understand the constructability aspects. So,
would you say that overall, would you classify River Beach as a hybrid?
Yes,
So-called
and
hybrid project?
that's, I think, an important point. When we first started the research, we took an approach 100% timber, everything, the cores, the connections, just everything, which you could do. It's not very practical, So we started to find that harmonization, I guess, of where timber was appropriate, where steel is appropriate, where concrete's appropriate. And I think one of the greatest things about being an architect is you're sort of forced to be objectively neutral when it comes to materials. And I always like to think of it as best material for the right application, and then it's really just a process of iterating through all the potential solutions of that until you get to the right one.
Well, and it seems like, just from a pragmatic standpoint, that approach to using the material in concert with steel and concrete is the way to really get it more rapidly adopted, right, into projects. So it's great to see that you're thinking about that. So what is mass timber capable of, structurally speaking? You're going at 800 feet here, right?
800,
hypothetically, right?
Yeah.
But I think you alluded to that's not necessarily the limits. That's just the number you pegged as something to give yourself a constraint.
It was a number
to
get a constraint and have a result that we could just look at and say, okay, this works.
Yeah. So even though Perkins&Will may not intend to build the project itself specifically, do you see this sort of spawning tall timber eventually?
Yeah, and I think every material has its constraints, limitations. You basically get three materials to work with: steel, concrete, and timber. And I think the engineering and the science behind each of those is different. So even though this was 800 feet tall, and we arrived at potential solutions for that particular iteration of it, a lot of what we learned on the tower scales itself down or up in a variety of applications. And it is, I think, the sort of hybridization opportunities where, how can the material start to work with other materials based on the condition you're trying to solve for, right? Like, say a 6-story all timber building is a little more manageable than an 800-foot tall, out of the same. You're going to have different details. You're going to have different considerations depending on the project type. So exercises like this help us get ahead of the game on just current projects that we're going after. I did a little research within our firm before last week. In 2016, when we started River Beach, as a firm, we had 17 timber projects up to that point, mass timber, not of different heights and scales and whatnot. So then between 2016 and now, there's 27 projects within the firm.
Wow.
23 of those are within the past 3 years.
Projects that are built or
they're either on the boards,
proposed.
built.
Yeah.
But what I thought was really interesting going back and looking at those statistics is that last point of, even though there's 27 of them that have come online since 2016, 23 of those are in the past 3 years. So there's this sort of rate of acceleration that's just, really interesting to see where
So is
where
it a
can take
stretch
us.
to sort of say that the pushing the boundaries in structural design research, the way you're doing River Beach, is making simpler projects more possible?
It puts a, I think whenever we start a project now, there's all the environmental benefits and things like that, but I think we're able to start at a much more informed point at the beginning of a project. So you're able to more quickly, now that codes are adopting and things of that nature, we're able to have a broader palette of how we can think of things at the beginning, which is really important, for how a design evolves. And the fact that timber is a part of that conversation now early on, just, it's a nice thing to see.